Okay, Math 1 class today we're talking about special systems, special systems of equations. And our essential questions are, can a system of linear equations have no solution? Can a system of linear equations have many solutions? First I want to talk about all of the methods for solving systems of equations that we've learned so far. And the first one is graphing. So, when we graph a system of linear equations, we know that the solution is wherever our two lines cross. And the best time to use graphing is either to estimate the solution, and that's just assuming that you're not using a calculator. If you're using a calculator, it's always good to graph. The graphing calculator is the only exception to that. So if you're using the calculator, you can probably find your answer. Graphing is probably the easiest route to go. The next way that we learned to solve systems was using substitution. And the best time to use substitution is when one of the variables has a coefficient of 1. So that it's easy to solve for that variable and substitute in whatever that variable equals. The best time to use elimination is when at least one pair of like terms has the same or opposite coefficients. And then there's elimination, where you have to multiply the first, and that's the best option when one variable can't be eliminated by adding or subtracting the equations. Each of these options will work for any system, so you are free to choose whichever one works best for you. Okay, moving on, we're going to talk about the possible solutions of systems of equations. And first, one solution, which is the most common, when we have one solution, the lines intersect, and everybody's happy. There's one solution. It makes life simple. When there's no solution, the lines are parallel. They never cross. They're always going to be the same distance away from each other. So there's no solution for that system because they're never going to cross. And when there's infinitely many solutions, the lines are the same. So the equation of the line is the exact same. It's one line on top of the other. So every single point along the line is a solution. So the lines are the same. Okay, so let's take a look at this set of problems. How do I solve systems with no solution? Well, here I can see that we have parallel lines because our slope is the same, but our y-intercepts are different, so I know they're not the exact same line, they're just parallel lines. So, and I can see that really obviously, so there's not really any work that we have to do except for to write no solution. Same thing here, I can see pretty clearly that my slopes are the same and my y-intercepts are different. So they're two separate lines and they have no solution because they're never ever going to cross. On this third one, I have some more work to do because I don't have two equations that say y equals, so I need to subtract 5x. Here I have y equals negative 5x minus 2. Here I have y equals negative 5x plus 0. So my slopes are the same, which means they're parallel. My y-intercepts are different, which means that they're parallel. So I have no solution. If you wanted, you could have graphed every one of those. You could have seen that they were parallel and said also that they are no solution. On the next set, I have a system of equations with infinitely many solutions. And infinitely many solutions means that we have the exact same equation. So here I'm going to subtract x to see if this equation, when I solve for y, comes out the exact same. Subtract x again, but here I have to divide by negative 1. So y equals 3 minus x on the top equation, and y equals negative 3 divided by negative 1 is 3, negative x divided by negative 1 is positive x. So I don't have infinitely many solutions because my equations are different. My slopes are the same, so this is going to have one solution. And you could find that by graphing, substitution, or elimination. On the next one, I have to subtract 2x from both sides, and then subtract 4x from both sides. And on the bottom equation, I have to divide by 2. So on the top equation, I have y equals 5 minus 2x, and on the bottom equation, I have y equals negative 2x. And again, now I have parallel lines because our slope is the same, but my y-intercept on the bottom equation is 0 and the top is 5. So these are parallel, which means there's no solution. And on the last one, we're going to solve for y again. Subtract 2x from both sides, divide by negative 4. So I get y equals negative 1/2 x plus 10 over 4. And here I'm going to add 12x, divide by 24, and I get y equals 1/2 x minus 60 over 24. And we can see that our slopes are different, so there's just going to be one solution, which we can find using graphing, substitution, or elimination. I want you to go ahead and try the 4 practice problems for your homework assignment. You need to tell if they have 0 solutions, 1 solution, or infinite solutions, and if it has 1 solution, you need to go ahead and find it. Have a great night.